Alright, in this video I'm going to be teaching you the proofs of our logarithm properties. So that's the product, the quotient, and the power. So let's start with the product. So as you know, the product property is log base b. I'll be doing some color coding in this video, as I tend to, of m times n. Okay, and if you have that product, it is equivalent to log base b of m plus log base b of n. Alright, so let's do the proof for this. The proof, we're going to start by defining x and y. So we're going to let x equal log base b of m. And we're going to let y equal log base b of n. So that's what we're going to define. Alright, so if that is what x and y are, then we know we can rewrite this as b to the power of x equals m, and b to the power of y equals n. Okay, so that all being said, we'll start our proof by multiplying together b to the power of x and b to the power of y so that we have m times n. So b to the power of x times b to the power of y is going to equal m times n. Right, and that's because of what we are given right here. Right, so now we're going to just manipulate this. So if I have b to the power of x times b to the power of y, I can use the product property of exponents. Why is that so hard for me to say right now? So I'm going to rewrite this as b to the power of x plus y. And that is still equivalent to m times n. Okay, now I'm going to rewrite this whole thing in logarithmic form. So I'll have log base b of m times n equals, what's up here, x plus y. Alright, now as you can see, we've got the left side of the product property, and we're really close to having the right side, so all we need to do now is replace x and y with what we define them as. So that means that log base b of m times n is in fact equal to x, which is log base b of m, plus log base b of n. And that's the proof of the product property. So let's do the quotient property next. Quotient property . So the property itself is log base b of m divided by n is equivalent to log base b of m minus log base b of n. Now, this proof is going to start very similar to the last one. We're going to let x equal log base b of m and y equal log base b of n, which means b to the power of x is going to be equivalent to m, right? So I'm just rewriting this. And b to the power of y, and b to the power of y equals n. Alright, so because this is the quotient property, we're going to start with a quotient. We're going to have b to the power of x over b to the power of y. So b to the power of x divided by b to the power of y, which means that this is going to be equivalent to b to the power of x is m. This is going to be m over n. Okay, now using our quotient property of exponents, I can rewrite the left side as b to the power of x minus y. And that is still equivalent to m divided by n. I bet you could even pause this video and try to finish the proof on your own if you're interested. So at this point, I'm going to rewrite this as a logarithm. I'm going to write log base b of m over n. Oops, I changed the colors. Should fix that. Too much color coding. Of m over n equals m over n. Sorry, equals x minus y, right? Log base b of m over n equals x minus y. We're rewriting it. Okay, so I just rewrote it using my definition of a logarithm. And now we have the left side of our quotient property, we just need the right side, so we're just going to substitute in what x and y are as logarithms, and we are finished this proof. So log base b of m divided by n is equivalent to log base b of m minus log base b of n. Alright, so we have one more property that is the power property. Alright, so the power property is log base b of m to the power of n is equivalent to n times log base b of m. Alright, so for this proof, be a little bit tighter on room for this one. For this proof, we're going to let x equal log base b of m. And if x is equal to log base b of m, then we can rewrite this as b to the power of x equals m, right? Definition. All right, so this proof is a little bit different than the others. I'm going to start with what I know as m equals b to the power of x. All right, and this is going to have a bit more manipulation to it. So I'm going to start by raising both sides to the power of n. So that's where my n is going to come into play. Okay, and then I'm going to use my exponential power property to rewrite this as just m to the power of n, and this as b to the power of x times n. All right, now this is where it's a little bit different. So remember, as long as I'm keeping both sides equivalent, I can do whatever I want to both sides. Now I'm going to take log base b of both sides. And I'm specifically doing log base b. I'll explain in a minute. So I'm going to do log base b of m to the power of n. So I'm just taking the log of both sides. And maybe you can see why I'm doing this. So I'm specifically doing log base b because log base b of b equals 1, right? Remember that? So because log base b of b equals 1, this is going to stay log base b of m to the power of n. But the right side, these will cancel, right, because they're just 1, and I'm going to be left with x times n. So we now have the left side, right? We've had it for these two lines. What I'm going to do now is replace x with what we defined x as. So this is going to be log base b of m to the power of n. We're really close to the end. And instead of x, I'm going to have log base b of m. And we're going to now use a property, right? Because this isn't quite what we want. We don't want the n in front of this logarithm. We want it behind it. So I can use the commutative property of multiplication and just move it behind, right? 2 times 3 is the same as 3 times 2. So the order does not matter. That is the commutative property of multiplication. And we have now finished the proof. Log base b of m to the power of n is equivalent to n times log base b of m. And those are your 3 proofs. So we have the power, the quotient, and the product. Hopefully that will help with your understanding of these properties.